Hello, my name is Ahmed Al-Hanini, and I will make a small presentation about the OSPF. So, what we mean by the OSPF is the Open Shortest Path First. The main idea of this algorithm that it see everything as a node. Firstly, it is used the SPF algorithm that made by Digestra. The O is referred to the open standard. The OSPF was created by John Moy. As these nodes connected to each other and have a start point and an end point with maybe many different ways to find the end point. So, the OSPF works to find all the possible paths from the start to the end, and it's choose the best one, the best path, depend on the cost. The cost here is the bandwidth. The OSPF type is linked state, and what we mean by the linked state is every router connected to the network know all the information about all other routers are connected, whatever there are, and all the paths outside the network. The OSPF protocol is a UDP with a port number of 89. Let's start by the first phase, at startup. What will happen on the startup? OSPF running on this router, this router, this router, many routers. R1 will send a neighbor's discovery to all the routers connected with it. So R1 will send a neighbor's discovery to router 2 and to router 3. Also router 3 will do the same and router 2 will do the same. Router 2 will send a neighbor's discovery to router 1. It cannot send to router 3, that is neighbor. But R1 is neighbor with router 3 and router 2. But router 3 also is only neighbor with router 1. So it cannot send a neighbor's discovery to router 2. This message will be sent as a multicast message on a group 5. What we mean by group 5 is the 224.5.0.0.5. That's the group 5. What we have in this neighbor's discovery, it has a hello packet. It's a hello message and will be sent to the routers from router 1 to router 2, from router 2 to router 1, from router 1 to router 3, from router 3 to router 1. When router 2 received it, the router 2 reveal its information and compare what it has in this message, in this hello message, with its information, with its self information, compare it to each other to see some condition. These conditions must be the same on both routers. So, let's talk about these conditions. First one, they must be on the same network ID, the same subnet mask, direct connected to each other, same dead interval, same hello interval, same auth and auth types, and same area ID. Now, what we mean by same hello and dead interval. Both routers are keep sending each other a hello message every hello period of time. Let's say it's 10 seconds. There will be a counter, right? This counter for the hello message, as we said, is 10 seconds. the dead message will be 40 seconds. So the hello will start at 10. When it's 10, the dead will start count also at 40. The hello message at 9, the dead will be 39. And that will go on until 0. Okay? When the counter has reached to 0 here, the dead will be 30. Now, router 2 will suppose that router 1 will send it a message, a hello message. If it didn't, the dead counter, dead interval, will still count until 29, 28, until it became a 0. When a router became a 0, or the counter became a 0, for the router 2, that means router 1 has disconnected from the network because it didn't receive a hello message from it, and will remove it from routing table. Now, why we do need all the routers at the same time? As if a hello message time on router 1 was more than the dead message on the router 2, the router 2 will delete it from its table, right? And that's wrong because it's still connected, but it was wrong in timer, nothing disconnected. Now, what we meant by same auth and auth type. If the router 1 has the auth of MD5, router 2 and all the routers on the network should have the MD5. If router 2 or router 1 has the SHA-1 or SHA-2 or whatever, all the routers on the network must have the same type of auth. Now, after router 1 and router 2 compared their information and became neighbors, database exchange, that the phase 2. Database exchange, in this phase, all the router will exchange their information with each other. Let's see how that's happened. Now, every router will create an LSP linked state packet for itself that has information for the link connected to the router. So, R1 here, how many link has on it? 1, 2, 3. So it will create 3 of LSP. Router 2, it has 2 wire connected, that's serials. It will create 2 LSP. Now, what is LSP? What it has information in it? It has the network ID, the IP, the type, the host, and the neighbor. For the network ID, let's say we will start with this one. For the network ID, here it's 172.27.0.0/24. The IP will be 172.27.0.1. The type, this is the cable type. We use here a serial because it's between routers. The cost, every serial or every cable has its bandwidth. So the serial here have 5 cost. So let's type just 5. What's the connected router on this serial? We don't know, so we'll set none. The LSP2 or the 4.3, whatever, or let's say it's 10. So it's 10.0.0.0/30. and the IP will be 10.0.0.1, the type also serial, the cost it's 20 here, and the neighbor. Now for the router 1 and this serial, router 2 is its neighbor, so we type here router 2. That's it. I will complete this and return for you. Now LSP plus another LSP plus another LSP, so more than one LSP together, called LSA. LSA, that's mean linked state advertisement. Now router 1 will take all these LSA and send it to its neighbors, just its neighbors. So router 1 cannot send it to router 3, it send it to neighbors, to just router 2. Also, that's using floating that we talked about. It's 224.0.0.5 on a group 5. Now router 2, it has the same information about itself. It will send it to its neighbor, so it will send it to router 3, also it will send it to router 1. Now router 1 will delete all the same information that it has from and received from router 2. So what is the same information? This one, and we'll just leave this one. It's deleted as randomly. Now after the neighbor send the LSA to each other, they will have something called LSU. What we mean by LSU? That is a linked state unit or linked state update. That LSA plus LSA. That's LSU will send to every single router on this network until all these routers on the network became synchronized, and we called it LSDB, linked state database. Now this LSDB, they put it in their each topology table to use it when send a message to, as they know, the best path. And for that, the OSPF, it has all the information from each router to other. So router 1 now became know every single information about router 3, our cost, and what is the best path of to reach it. Now after we run the OSPF and all the router became know each other best path, let's see how the digester will work. Firstly, it's kind of draw a tree for each path it has. So what are the paths that could take from this start point to reach router 5 or this network 10? It will choose the least cumulative cost, and it became the best path, and it will save it inside its routing table. So for this example, if it starts from here, so it has two paths, this path and this path. The first path from router 1 to router 4 to router 5, and that will give us 20 plus 10, that's a 30 cost. The other path from router 1 to router 2 to router 3, then to router 5, and that will give it a 10 plus 5 plus 5, that's a 20. So the best path here, the least cost, and it is the 20, the second path. And that was all for this OSPF. Thank you for watching. Bye bye.